What's going on, fellas? Got a quick little experiment here for Jonas in Sweden. Alright, so we got a slight demonstration of what a vessel this size can do. One thing I truly dislike is the side discharge. Even though the vortex catcher is in the center of the cyclone somewhat, it stops about right here. Because of the way it's set up, the flame has no reason to propagate into this top region. It really doesn't. And when you look in there on low burn, you can see there's no fire up here. And that's a problem for several reasons, okay? Now, if we have a top discharge, a couple of things are going to happen. The fireball now has no choice but to go up out the center vortex. So now we have fire migration. We are forcing the fire to migrate to a cooler area in the burner. And that's going to preheat this incoming air. We're not getting hardly any preheat here at all. This top area is very cool at some operating settings. We don't want that. So we got all this metal up here with the fireball shooting out of it. Now we've got this big hot plate with a fireball blasting on the side of it. You can see here how the front kind of shows a hotter zone over here versus a cooler zone over here. We can change that. If we migrate the fireball out the top of this unit, not only will a fireball be emanating radiant heat in that area much closer, but it will also be heating this top plate, getting it warm, which is in turn going to preheat the air better. And air preheat is a huge deal. It's a big deal in some cases, especially in a case like this. Even though the wood's all down here, watch what a little bit of air preheat can do. Preheat goes a long way. Check that out. We are getting a lot of blue flame, guys. You can't see it in the camera. Guys, I don't have enough time tonight to do the fuel consumption part of this video, so that'll be coming up tomorrow. But we did eventually get this thing blazing red hot, and it's definitely ready for the job. This thing is blasting hot, guys. 1400 degree combustion, 1500.